Good evening, everyone. I hope everyone is fine and you did enjoy the last lesson which we had few days ago, and it was till the fifth law of indices. So today we are going to be starting with the new law of indices. We may call it law number 6. We may call it law number 6, or simply this law number 6 is called 0, bear with my writing please, 0 indices. Okay, now how we actually calculate this 0 indices? The law says that if we have a base and the index is 0, then this entire thing will be equals to 1. Now this base could be an alphabet or it could be any number, right? This is going to be a constant thing because this 0 will make it, the entire value will be equals to 1. It will make it 1. Okay, so this is law number 6. You may call it law number 6, you may call it 0 indices, but this is how we actually solve it. Now moving on to law number 7, that when we talk about indices, we name them with laws or definitions, or we simply name them with the function they are going to be doing. Why am I saying that? Because in the next law which I'm going to be describing, you can call it law 6 for your own memory, but at the same time that law is actually about the radical value of a number, right? So how do we write it? We just say that if b is equals to this is actually the law, right? If b is equals to, or in fact we'll write it a. If a is equals to b power n, then this b will always be equals to radical expression of that number. Now remember, this is called radical sign. What do we call it? We call it radical sign. Okay, so please do not forget that this is called the radical sign, and this is law number 6, that if a is equals to b index n, then b, if we want to calculate the value of b, then b is always equals to the radical nth root of a. When we'll solve it, I'll write the these laws at the top of the page while solving the questions, and you will actually be understanding them more clearly once you'll solve the questions. Okay, now next law. I'm going a little fast because once we'll solve the question, we keep on repeating the solution of questions while using these laws, so that's not going to be very difficult for you. So that's why I'm writing it. Now law number 7 is, moving on to law number 7. Law number 7 is that 1 over base power index, this is equals to, again, radical sign n a. Okay, this is actually the rational indices. Okay, we also call this law number 7 as rational indices. Okay, so I would request you students that you must have a notebook or something with you. I know you might have the books with you where these laws and everything is written, but once you're gonna just write it with your own hands while understanding it from this video, it will be easier for you, plus you'll keep that in your mind at what we are talking about. So this is actually definition number 3 while using the positive integer, that if a power if the power of a is 1 over n, that means it is actually the nth root of a. Let me give you an example of this law number 7. If I write a power 1 over 2, this is actually under root a, because this thing is actually always equals to 1 over 2. So you can write it like this, or you can write it like this. It's one and the same thing. Okay, this is just for 2. I'm not saying that for every number we can write it this way, no. But whenever we have the half as the index of a number, it is actually the under root of that base. Alright, but at the same time, if we have different number in the denominator of the index, then that is that number's root. Okay, what I'm talking about is, if I'll write 3 here, then under root will come, definitely it will come, but the power or the index of this under root will be 3. For example, if I'll write 1 over 5, then the power of this a will be 5. I hope it's clear. Only for half, this half thing is actually equals to this under root. Whenever we are writing any value in this under root, it means it has half as its index. Okay, so this is law number 7. Now the last law. We did today, अभी तक के लिए अगर मैं आपको वापस लेके जाऊं स्टार्ट में, तो हमने क्या किया है, what was the first thing that we did? We did 0 indices, right? Then we did which one? We did, the second one was indices with radical sign. That was a is equals to b power n, then b is equals to under root of a with nth its power. Then we did next law, which was rational, where the power is 1 over n and it is always equals to the root, under root of a with power n. We will be doing these 3 today, and I will be introducing the 4th one, the definition of the next one. Now, the last rule of indices is, if we have a index m over n, then this thing is always equals to a nth root whole m. Okay, this is your law number 8. It's a law of integers. Again, you may call it a rational indices too. So these are basically the left ones, or the 4 last rules or signs or definitions or laws of indices. Okay, so now let's start with chapter. Today we are going to be starting chapter number exercise number 4b of the same chapter which we were doing earlier. We are done with exercise number 4a. So now, starting with the exercise, we have basic level in 4b, exercise 4b, question number 1a. Question number 1a is 17 power 0. Now, what was the law regarding zero indices? It was a power 0 is always equals to 1. So what will be the answer of it? 1. 1 is the answer of it, because 17 has got the power 0, which made this thing equals to 1. Now B, minus 2 over 7 whole power 0. I'm sure you know the answer. When the power is 0, the entire thing will be turning into 1. It will turn itself into 1. That's question number 1B. Okay. Now question number 1C, which is quite interesting. If you have the book in front of you, we are doing D3 Chapter 4 exercise 4B. Part C says it's 4D power 0. Now you tell me what will be the answer of it. This is the multiple. We are not going to be transforming this or converting this number into 0. Remember, the value or the digit which has the power 0 will be becoming 1, not the multiple of it. Okay, so what will happen? It will become 4 multiplied by 1. This whole thing will become 1, which is equals to 4, and 4 is the answer. It's quite interesting, right? Now we have D part. In D part, we have minus 8B power 0, which will become minus 8 into 1, and the answer will be 8. Right? That's the answer. So I'm quickly going to be moving to the next question, which is part E. I can leave these questions on you. I just want you to at least look at them while understanding them, and you may practice it later on your own. But once अगर आपका दिल नहीं भी कर रहा है करने के लिए, at least while you are looking at it and you're watching it, it might be there in your mind at how to go about it. Question number E is very interesting. 72 C D square, and this whole thing becomes 0. The entire thing has the index 0 as its power. So what will happen? This entire thing has 0 power, means this entire thing will become 1. So do not forget that you should not be getting confused if we have a huge kind of a number with many multiples or squares or cubes or under root within the brackets. If the power is 0, the entire thing is gonna go in waste. It's gonna be becoming 1. Nothing will happen with the value except that we are turning it to we will be making it 1 equals to 1. Okay, now question number F. Question number 1 F. Question number F 1F says 7 E power 8, this whole thing power 0. Again, 7 is outside. It's a multiple and it does not have this power 0 with it. So it will become 7 into 1, and the answer will be 7. Okay. I hope it's not very difficult. So now we will be moving towards question number 2 now. And I'm sure that law number 1 regarding 0 indices, now it's clear that whenever power is 0, the value will be becoming 1. Now, question number 2. Question number 2 says, find the value of each of the following. Find the value of each of the following. Okay. Please bear with me, because again, I'm trying to just use this mobile to teach you via using that whiteboard thing. I hope it's not going to be very annoying. Question number 2, part A. We have 2 power 0 multiplied by 2 power 4. Now, if you remember, what is law number 1 which we did? If a power n multiplied by b power m will be equals to, sorry, this is the same one, is equals to n plus m. Okay, so here we have law number 1. At the same time, we have the 0 indices law there. So what will happen? This will become 2 power 0 will be becoming what? There are 2 ways to do it now. One, we can simply write 1 into 2 power 4 is equals to 2 power 4. Or we can use law number 1 and we do it as 0 plus 4 is equals to 2 power 4. In both ways, you'll get the same answer. So you can use law number 1, or you can simply use this 0 indices law and solve it. In both ways, it's correct. Okay. Then we have question number 2. B, and question number 2b says this is actually the problem with erasing it. I'm not very used to of it. Kindly bear with me. I will actually be very humbled if you will bear with me. Okay, moving on to question number 2b. Question number 2b. Now again, they have made a combo of 3 different laws. 7 power 2 multiplied by 7 power 0 divided by 7. So what will we do? 7, 2 plus 0 over 7, which is equals to 7 over 7. This 7 does not have any value. It means it has the value 1. So it will become 7, 2 minus 1, which is equals to 7. And this is the answer. Okay. If you're not clear, let me do it again. Again, there are 2 ways to do it. You can use law of this 0 thing, and you can simply cut the indices later on. How we will do that? 7, 2 plus 0 over 7, which will become 7, 2 over 7. Now here what we can do, we can the best way is to use law, and how we'll use this law? 7, 2 minus 1. This will go up there. It has power 1, so it will become 7, 2 minus 1, and 7, 1 will be left, and this 7 is the answer. Or if I'll do it myself, so what will I do? I'll just simply cut 1 with this, and we'll be left with this 7, 1, power 1. So in both ways, it's correct. So whatever is easy for you, it's better to use the laws. I mean, once they're going to be in your practice and you are quite comfortable and you already know that which law is going to be used, then it's quite easy for you to even, solve it directly. so that's not going to be a problem, but you need to practice it more so that I still remember हम लोग के बड़े क्या करते थे, my teachers used to tell me that जो भी चीज़ आप सीखना चाहते हैं, at least once it should go through your pen and you will never forget it. So I would recommend that practice them at least once before your exams, and then it's going to be very easy, because once you do it, it's going to stay somewhere in your mind at how you did it. Okay? Then we have question number 2C, and 2C says 8 power 0 minus 8 square. So it will become 1 minus 8 square. We'll open square. 1 minus 64, and the answer will be minus 63. That's the answer. Okay, not very difficult. Moving on to the next one, we have question number 2D now. Question number 2D says 6 power 3 plus 6 power 0 minus 6. So what will happen? We simply open it. We won't make it more. 6 into 6 into 6. 6 cube is equals to 216 plus 1 minus 6. Right? So we'll have 210 plus 1. 211 is the answer. Okay? Not very difficult. Very easy. Again, just needs your practice. Then we have reached to question number 3 of 4B. Question number 3 of 4B says evaluate each of the following. Now what is that each? Let me write it for you. We have question number 3A, and question number 3A says 7. Okay, in question number 3A we have 7 minus 3, which means we have 1 over 7 power 3. Right? This inverse, to remove this inverse, what will we do? Just to make this value or the power value positive, we'll just put it in the denominator. So it will become 1 over 7 cube. And you know that 7 into 7 into 7 is equals to 343. Okay, so the answer will be 343. This is the answer. All right, now question number 3B. Question number 3B says, wait. Question number 3B says minus 5 whole power minus 1. So again, what will we do? We'll make it, we always put the value in the denominator when the power is in negative. It will not change the sign of this base value. It will only be changing this negative index into positive index. So in this case here, what will we do? We'll just put it again in the denominator, and it will become 1 over minus 5 power 1, which is equals to 1 over 5. That's the answer. 1 over minus 5, sorry, because this minus will not change. Okay, so that's the answer of it. Now question number 3C. I think you should be doing it. Question number 3C now. Or in fact, you should do question number 3D. Let me do 3C for you. And this D is quite simple, and it's quite similar to question number 3C. Question number 3C is 3 by 4 whole power minus 2. What will happen? We'll take this entire thing, 3 by 4 square in the denominator, to remove this negative sign. Now, what will we do? We'll open it. 1 over 3 3s are 9, 4 4s are 16. Now again, whenever we have two denominators, so the one right under it, or the one which is under the second denominator or fraction sign, will be coming at the top. So it will become 16 over 9. Remember that whenever we have a denominator under denominator, then the second denominator will be becoming the numerator of the first fraction. Alright, so this is 16 over 9. Now what will we do? We'll divide it. Nine, and we left with 7, and it will become the fraction 1 7 by 9. This is the answer. Okay, this is the answer. Fine. Now question number D is going to be done by you now, because it's quite same. Since it doesn't have that power 2s or 3s में तो नहीं है, but it is in negative, the index is in negative, so you need to solve it yourself. I'll be moving to question number 4 now. In question number 4, evaluate each of the following. Question number 4A says 7 square whole power minus 2 divided by 7 minus 4. So they try to make it quite, a complex kind of a question, but it's very, very easy. So you don't have to worry about it. What will we do? We'll first solve this division thing. We'll write 7 2 whole minus 2 divided by 7 power minus 4. This will become, that as per law 3, we need to multiply them. So it will become 7 minus 2 2s are 4 over 7 minus 4. Now if I want to do it, I'll simply cancel it. Okay, but in fact you can do it as well, but it's better not to do it in this way. How? Because once you'll take it up there, it will become plus, and the answer will be 1. Okay, so we'll cut it, same values, and answer is 1. Okay, so 1 is the answer. Just the same values, opposite directions, or a denominator and numerator thing, so you simply cancel it and the answer will be 1. Now question number 4B. In question number 4B, we have 5 power 0 minus 5 power minus 2. So this will become 1 minus 5. In fact, we'll just take it in the denominator since the value is 5 square. This is 1 minus 1 over 25. We'll take the LCM. So 25 minus 1 over 25. This will become 24 over 25. Simple. That's the answer. Okay. This was question number 4B. Okay. Now question number 4. 4C says 2 power 15 whole power 0 plus 3 over 5 whole inverse. Minus 1 is normally the inverse. So this will become 1 plus, we'll take it down, 3 over 5, 1, right? So if we'll just again, denominator of the denominator will come up and it will become 1 plus 5 over 3. When we'll take the LCM, it will become 3 plus 5 over 3, 8 over 3. So if we'll divide it, 2, 3 2s are 6. We're left with, so the answer will be 2 whole number 2 by 3. That's the answer. Okay. I'll try to write more smaller now, because then one question will be covered on one page. Otherwise, I'll be moving to the next page next time. Question number 4D. 4D has got multiplication in it. So it's a little lengthy question. Let me solve it here. Though I know that if you will try, you will be able to do it, because we just have to implement all the laws, or at least a combination of different laws of indices. But let me do it here. So once you see how to solve it, once you practice it later on afterwards, then you will actually be doing it correctly. So the question is, 4D is 3 by 4 whole minus square multiplied by 3 square multiplied by 2015 power 0. So let's simplify it first. We'll have 1 over 3 by 4 whole square multiplied by 3 square multiplied by 1. You know why I made it 1. So this will become 4 by 3 square multiplied by 3 square multiplied by 1. Now I simply will be open it. If you remember the law, what was the law? A over B whole n is equals to A n over B n. Remember? So this is how I will solve it. I'll write 4 square over 3 square multiplied by 3 square multiplied by 1. This will be cut with this one, 4 square, which is equals to 16, and that's the answer. Right? What we did, we simply, in the second step, we took the entire value under 1, and then denominator of the denominator came up. The entire thing was with the square, so we put that square. This thing as it is came over here, and this zero indices made it 1, so I took it forward, and on the next page you can see when I solve it, I simply cut 3 square with 3 square. 1 was as it is, 4 square was as it is. Once we open this 4 square, it has become 16, and that's the answer. Okay, that was question number 4D. Now, question number 5. In question number 5, 4B, exercises 4B, 5A, they said under root of 196. Right? Under root of 196. We need to see that whether we can actually solve it with that under root thing, because as you remember, under root means power half. So let's do it with the LCM method. 196, we did it earlier as well in our first lessons. 2 9s are 18, 2 8s are 16, 2 4s are 8, 2 9s are 18, 7 7s are 49, 7 1s are 7. If you check my YouTube channel, if you have subscribed, I shared that we normally use the prime numbers to check check whether the number is prime or composite, and then we solve the under root 2. So I'm using that method. So my very short clip of prime number is there on my own YouTube channel, so you can check it over there. Right, so what will we do? It's 2 square into 7 square actually. So it means this will cancel the under root. This square will cancel the under root, because this actually has become 2 multiplied by 1 by 2, 7 square multiplied by 1 by 2 if I remove the under root. So this will cut 2 into 7. This is equals to 14. So that's the answer. Okay, keep watching the video and you will understand if you did not understand it, because I know I was a little quick. But if you will check out that video of prime numbers and composite number, you will understand that what is prime factorization. This is actually the prime factorization. Okay, and it was I think prime factorization was in the chapter of sets, chapter number 1. Anyway, now moving on to question number 5B, which is 125 cube root. Okay, this is very simple. Again, it's a prime factorization. If you know the cubes, if you remember, I told you that you need to remember the squares and cubes of at least first 20 numbers. Then it's going to be on your tips. Even then, if you don't remember it, you simply just do this factorization kind of a stuff with this LCM technique. 125, 5 2s are 10, 5 5s are 25, 5 5s are 25, 5 1s are 5. So this is 5 into 5 into 5. This is 3 under root 5 cube, which is actually 3, 1 over 3 and 5. Okay. So moving on to next question, 5C. 5C says 5 1 over 32. So 32 is an even number. Simply come in the table of 2. Again, LCM technique. 2 1s are 2, 6, 2 8s are 16, 2 4s are 8, 2 2s are 4, and 2 1 is a 2. So 1 2 3 4 and 5 times again. So it will become 1 over 2 into 2 into 2 into 2 into 2. So 1 over 2 power 5 whole 5. This 5 will cancel with this, and 1 over 2 will be the answer. Okay. Now I'm leaving this D on you. It has 16 and 81, and the under root has got the power 4. Let me just write it here. It's 4 16 over 81. This is going to be 2 power 4. This is, I think, going to be 3 power 4. So 2 by 3. I think this is going to be the answer. So you need to check it now. Okay. Moving on to question number 6. They said rewrite each of the following in the radical form. And I hope you remember that this is the radical form. And if we don't write any index here, means the power is 1 by 2. Otherwise, this will have this n power, n could be 1, 3, 4, anything. Right? So this is radical sign. So how we will solve it? We will simply, they said that they are giving us the questions, and we need to, without using the calculator, we need to write the radical form of it and solve it as well. So question number 6. This is going to be the last question I'll be doing for today's lesson, and then we'll do question number 7 to onwards, intermediate level, and rest of the laws practically, inshallah, in a day or two in my next video. Okay, so let's do this question number 6. Question number 6, part A says 81 power half, and as I said, this under root means 81. And now this 1 over 2 needs to be cancelled. 81 is the square of 9. And 9 will be the answer. Why? I just wrote 9 because this under root without any n power means the power is 1 over 2. So when I write this, it will cut and become 9. Okay. 6b says minus 27 whole power 1 over 3, which is equals to 3 minus 27, which is equals to minus 3 into minus 3 into minus 3 whole power 3, which is equals to minus 3 cube 3, which is actually equals to minus 3 into 1 over 3. You cancel it, 3 with negative sign. Done. Now question number 6 C is 16. They said that do not use the calculator. 16 means under root 4 means 2 into 2 into 2 into 2, 4. This will have the power 4. This is 1 over 4. So it will become 2 power 4 into 1 over 4. Cancel. Answer will be 2. Okay. So if we have minus here, then this will become minus 2 into minus into minus into minus, right? Power 4. Okay. If I'll do it this way, if the power is 16 whole minus 1 over 4, it means it's 1 over 16 power 1 over 4, which means 1 over under root of 16 4, which is 1 over 2 power 4 into 1 over 4, cancel, answer will be 1 over 2 if the power is negative. Okay, then question number D, you must solve it. E of question number 6, you must solve it, and I will be solving. In fact, let me solve question number E for you, and D, F it must be done by you. Okay, question number 6 E says 8 5. Question number 6 E, we will be using the law 7 A m over n is equals to under root n a whole m. This was law number 7. So in question number 6E, question is 8 minus 5 over 3. Okay, 8 minus 5 over 3. So how we will solve it? We will simply first convert this negative power into positive by making it 1 over 8 power 5 by 3, which is actually equals to, according to this law, 3 will be the power, 8 will be inside, and this entire thing will have the power 5 over 1, which is equals to 1 over under root 3, 2 into 2 into 2, whole 5, which means 1 over 2 power 5, because that 3, this 3, this will become 2 power 3. So this 3 will be cancelled with this. So power will be left with 2 power 5. This 2 power 5, which I have written here, which is equals to 1 over 32. Okay, so this is it for today. If you have any confusion, any problem, any query, you can write under in the comments. Under the comments, any query, any question is fully welcomed there. So kindly please comment and let me know if there is any confusion. I'll be solving it again. Thank you so much. Take care. Bye bye.